Hi, welcome back to another Math 111 video lecture. Today we're going to talk about section 3.4, which is graphing, actually it's transformations and other graphing techniques. So I'm going to go ahead and give you my screen here. And let's talk about this. So what we're really talking about when we're talking about transformations, we're talking about being able to look at an equation and compare that to a graph of a basic equation. So what I mean by the basics is to check out page 224 in your text. And what we've got on page 224 in your text are some of our, what I call our library of basic functions. And what those are is the linear function, which is f of x equals x, and that just makes a straight line that goes through the origin, so it goes through the point 0, 0, and has slope 1. Okay? Now, the second one is f of x equals x squared, and this is a basic parabola. It goes through a few points. It goes through 0, 0, goes through 1, 1, and negative 1, 1, among others. We can figure out others, right? 2, 4, negative 2, 4, etc., and so forth. But those 3 points are enough to get us started. We've got the basic cubic, which is f of x equals x to the third. Yeah, so on. Goes through the origin, negative 1, and 1, 1. All 6 of these functions that are pictured on page 224 in your text, these are our basics. And the reason why we want to recognize these is because then we can recognize other functions that come from these. So let me explain to you what I mean by that. And what I want to do is I want to look at just our parabola, because it's pretty simple, pretty recognizable, but still interesting. The linear one is simplest, but it's not very interesting. So we're going to work with the parabola. And I'm going to get out my straight edge for just a second. And I'm just going to put myself a set of axes on here. So it's just an XY axis. Okay, and what I want to do is I want to graph the function f of x equals x squared. Now, if I put in x equals 0, I know f of 0 is going to be 0. And f of 1 is 1, and f of negative 1 is 1. F of 2 is 4, f of negative 2 is also 4. If you don't know how to get these points, be sure and get a hold of me so I can help you out here. 3 is going to be 9, 6, 7, 8. This is f of negative 3, which is negative 3, 9. And we have 3, 9. So what I've just done, and sorry, I'm not a very good artist. I should probably do this on the computer for you. But, so that's the graph of f of x equals x squared. Let's take a look at another function. I'm going to do this one a different color. So let's, in blue, take a look at f of x equals x squared plus 4. Now, if I start plugging in points, if I plug in x is 0, then f of 0 will be 4. 1, 2, 3, 4. F of 1 will be 1 squared is 1 plus 4 is 5. F of negative 1 will be negative 1 squared is 1, plus 4 is 5, right? F of 2 will be 8, 6, 7, 8. F of negative 2 will also be 8, and so on. And F of 3 will be clear up here. That's F of negative 3. This is F of 3. Okay. That's pretty close. Now, what I want you to notice is if I look at each of these points that I graphed, the vertical distance between those 2 points is 4. The vertical distance between those 2 points is 4. The vertical distance here is 4, and so on and so forth. In other words, this blue graph is exactly the same thing as if I had taken my black graph and just moved it up 4 points. So if I do this, I'm tracing my original line. And now if I scoot this guy up, it's going to lay right over the top of my other line. You probably can't see that. This is called a vertical transformation. Let me do another example here. So let's take a look at, suppose I can use this piece of paper, I'll just turn it over now. Suppose I have a random graph, and I'm just going to throw myself on a set of axes here again. And let's say my function f So suppose this is f of x. And I'm not even going to bother to try to define that function mathematically. I could, but it's not relevant to this conversation. But I want to, from just this graph, I want to sketch the graph of f of x minus 3. This will be a new function. That is my original one, minus 3. This means that I can take my original function and just shift it downwards 3 units because of this subtraction outside the parentheses. So I can sketch this graph by taking my original and counting down 3 at some key points. And then translating the shape in between those points. Okay, so these are all pretty much straight lines. This is called a vertical shift. And it happens, this vertical shift happens whenever you've got a subtraction outside the parentheses. So if g of x can be defined to be some function we recognize minus some number, f of x, then the graph of g of x is identical to the graph of f of x, except we just pick it up and shift it vertically a units. And we go up if we are adding a. We go down if we are subtracting a. Oops. Sorry. There you go. So I want you to think about that for just a minute. If we just add or subtract a number to the end of a function, then we pick up that function's graph and we move it vertically. All right. Now, let's go back to our parabola. Let's put my grids back on here. Let's go back to my basic f of x equals x squared. Okay. Now this time, though, instead of adding on to the outside, I want to look at a different function. I want to look at the function g of x equals x minus 2 squared. Let's just make ourselves a table. So x, g of x. If x is 0, g of x is going to be 0 minus 2 is negative 2 squared is 4. If x is 1, 1 minus 2 is negative 1 squared is 2. If x is 2, 2 minus 2 is 0 squared is 0. If x is 3, 3 minus 2 is 1 squared is 1. If x is 4, 4 minus 2 is 2 squared, which will be 4. So if we graph those points, 0, 1, 2, 3, 4, 1, 2, 2, 0, 1, oops, sorry. This is 1. 1 minus 2 is negative 1 squared is 1. So this should be 1, 1, 1, negative 1. So ignore that point and that point. And then 4, 4, 4. So my parabola looks like this. Now you notice it's the same shape as my basic, but it wasn't shifted vertically, was it? It was shifted horizontally. So if I count from here to here, we moved over 2 units. And there's my 2. From this point to that point, I moved 2. From that same point on the other side of my parabola, I moved 2. So on and so forth. This is what I call an adding inside. So we can think of g of x is the same thing as f of x minus 2. In other words, f of x was x squared. I replace this x with x minus 2, I will get my function. This is an example of a horizontal translation. So what I'm saying is, if I can take a function g of x, and if I can write that as some other function with an addition inside the parentheses, then the graph of g will be identical to the graph of f, except it will be shifted horizontally a units. So, and we go to the right if we are subtracting. We go to the left if we are adding. Now, it may seem a little backwards, but that's how it works. So let's go back over here to this example where I've got this random f of x. I did the vertical translation in red. Let's figure out what f of x plus 1 would look like. And we'll do that in blue. Now this plus 1 means we are going to do a horizontal shift. We're adding, so it goes to the left 1 unit. So we take each of our points and just translate it left 1 square. And then again, transfer our shapes in between those 2 points. In this case, we have no vertical shift, only horizontal. However, these things can stack together. Whoops, I did that wrong. That's not this. That's f of x plus 1. The addition is inside the parentheses. Now, I don't want to do it on this graph, so I'm going to make a new graph because it's going to get really messy if I do this on this one. But we can have both a horizontal and a vertical shift or translation. Shift, translation kind of means the same thing. So let's take my graph again. Just making a grid. Let's just sketch on here my basic parabola. Well, let's do my parabola, my basic parabola. 0, 0, 1, 1, 2, negative 2, 4, and 2, 4, and 3, 9. We'll just leave it with this. Okay, so this is f of x equals x squared. Now, suppose I tell you that I want to sketch the graph of g of x equals x minus 1 squared plus 2. The x minus 1, the 1 inside parentheses, tells me I'm going to have a shift to the right of 1 unit. And the plus 2 on the end means we're going to go up 2. This fact that we're squaring tells me that my basic shape is going to be the same as my f of x equals x squared. So I can take my parabola, and I can take each point on my basic parabola, and I can go right 1 and up 2. So I started from my vertex here, and I went right 1 and up 2. And I can take this point at 1, 1, and I can go right 1 and up 2. And I can start at this point, 2, 4, and I can go right 1 and up 2. And I can do the same thing on the other side of my parabola. Take this point at negative 1, 1, and go right 1 and up 2. This point at negative 2, 4, go right 1 and up 2. Connect the dots. And I get the same basic shape, shifted 1 and moved up 2. Now I'm going to minimize my my document camera, and we're going to take a look at Desmos for a minute, because Desmos is really good at this. So let me go to, remember Desmos is one of my favorite graphing utilities, and we're just going to launch our calculator. And let's play with f of x equals the square root of x. So this is going to be square root of x. And I'm going to make this guy he can be black and dotted. Okay. I'm going to turn this into projector mode so it's easier for you to see. And I'm going to drag my graph over. That'll do. Now, here's what I'm going to do. I'm going to do square root of x plus a. And Desmos is going to let me have a slider. And I'm going to go minus b. And Desmos is going to let me have a slider. Okay, so I'm going to set both a and b to 0. And when I do that, that's the square root of x plus 0 minus 0. You can see my blue line lies right on the top of my original black dotted line. Now, let's play with just the b value. Well, wait, let me make that a plus so it's easier to see. There we go. So if I make b positive, that means I'm going to be adding. So let's add 2. What's going to happen? My graph just shifted upwards 2 units. Same shape. If I take away that adder, that new line goes right back on top of the old one. If I subtract, what happens? So let's make this negative 2, which means really this is square root of x minus 2. Shifts downward, just like we expect based on what I said a minute ago. All right, so let's put this back to 0. And now let's play with the a. And the a, remember, is under that square root. If I add 2 inside the square root, what do we expect? We expect to shift to the left. Sure enough, I added 2, and my graph shifted left 2 units. This is like the square root of x plus 2. Its shape is the same shape as square root of x. It's just picked up and moved left 2 units. If I subtract, I get negative 2. Now, what happens if I've got square root x minus 2 plus 3? In other words, a is negative 2 and b is 3. We get both a rightward shift and a vertical shift. All right, I hope that helped. and I will talk to you all again soon. Have a great day.